So for this class, we do have a project. The project is called the Mini Golf Project. And in this project, you're going to design two possible 6-hole plus one practice hole. So you're going to have a total of 7 holes. And the practice hole is going to be a regular polygon and a miniature golf course. The two courses must have the exact same 6 holes, but moved around to different locations. The second design should have a different practice hole. Right. So what is going to happen for the project is you're going to have a first design and a second design. And for the first design, you're going to use GeoGebra, or you can use Desmos or some other technology. You can pick which one to create a 6-hole miniature golf course plus a practice hole. So in your report, so you're going to draw these using technology, and then you're going to kind of write a report about your miniature golf course. So in the report, you have to identify the coordinates of the corners of the holes, as well as the location of the actual hole or cup. You're going to also include the area and perimeter of each of the holes, so you'll need to calculate that. If any of the sides of the holes you design are parallel, they should be made in the same color in the GeoGebra design. In addition, you should use the angle measure feature to identify the measures of the angles that make up the corners of your holes. And if your holes can be made by composing polygons together, make sure to indicate how to compose those polygons to construct your holes. For example, a square plus a triangle, right? So that's your first, the design. I'm going to make another video on GeoGebra and show you how to do some of these things on GeoGebra. If you want to use a different technology, that's perfectly fine. You just need to find one that has kind of all the features that we're looking for. So after you create your 6 holes plus your practice hole, then you are gonna, for 2 of the holes, include obstacles. Okay, the obstacles should be made by combining platonic solids or other known 3-dimensional objects. And this is in unit 3. So this part is kind of the last part you'll do in the project. So for example, a silo from a cylinder or a half sphere, you're gonna have some type of obstacle within your, and within 2 of your holes. You do not have to put them on your diagram, but you do need to describe them in your report. So you need to say like hole 2 has an obstacle of blank. And this obstacle is composed of a cylinder and half sphere, something like that. You will have to identify the surface area of the objects and the amount of water needed to fill the objects. Amount of water is the volume. So you need the volume of the objects so that they can be grounded. For the practice hole, it has to be a regular polygon, which means all the sides and all the angles are equal. And you need to give the measure of the interior, exterior, and central angles of that polygon in your report. Around each of your hole, you will have to have walkways around all the edges of the holes. The walkway must be at least 1 block on the grid wide, all the way around. This means there must be space between all your holes to accommodate this. So when you're making your holes, don't put them all directly next to each other. Leave like at least 3 squares or so between each of your holes so that you can have the walkway. Determine the area of the walkways, and it says hint square counting. Again, we'll talk about area in unit 3. So after you make your first design and all of those things, you're going to make a second design. The second design is the same mini golf holes, except they're going to be transformed. So your second design should indicate how to transform the original holes to the new position. So you're going to reflect the holes or translate the holes or rotate them. And then you'll have to determine the area needed for the walkways with the new design. So you'll have to recreate the walkways for your new design and find the area. You need to do at least 2 different types of transformations. So you can't do, I'm reflecting all of these across the y-axis. That doesn't work. You need to do some reflections, some translations, or some reflections, some rotations. You need to pick at least 2 different types of transformations. And then after that, you're going to determine the cost. So your challenge is to cost out the construction of the golf course. You need to have wood around the perimeter of each of the holes. So you're going to determine the total cost of the wood to build all of the holes. You'll need to purchase the carpet to carpet the holes. So you'll determine the cost of the carpet to cover all the holes. Because of how carpet is purchased, you may need to purchase extra carpet. You must also determine the cost of paint to paint each of the obstacles and the cost of concrete needed to build the walkways, which must have a depth of at least 3 inches. If you're uncertain about cost, check out Lowe's or Home Depot on the internet. So you want to go to like Lowe's or Home Depot's website and look up the cost of wood, like wood boards that you would need to put around the perimeter of all the holes. And then you'll need to also look up the cost of carpet, like per square feet, and use that to calculate the amount of carpet that you need for your holes. Okay, and that will have to do with the area. You'll have to find the area of your holes and then use that to help you figure out the total cost for carpeting all your holes. And then you will also need to put concrete on the walkways. And so you'll have to, again, kind of find volume of the concrete. You're doing a depth of at least 3 inches, and then all your walkways will probably be rectangles. And so you'll have like length and a width with those, and you'll need to calculate how much concrete you need and then the cost of concrete. And then when you're done with your designs, in roughly 1 page, you need to follow up at the end and identify what technologies were used in your project and why they were used. Also indicate why you favored one technology over another based on its capabilities. Okay, and here are some basic GeoGebra tutorials and GeoGebra help videos that can help with that. So this is the one thing I am going to be strict with deadlines. So if you do turn it past the deadline, there's a 5% penalty for each day late. And the last day they will be accepted is Monday, May 15th, since that's the week of finals and I need time to grade them. Okay, so they're due on May 11th. Okay. And then there's a rubric. I would definitely read through the rubric to know what is expected, but I'm not going to read through that whole thing. So for the project, if you also go down to the project, it's mostly Dr. Mike's mini golf design. So there is an example of a golf course. Now you may not copy this example. So you should not have holes that are the same type of holes. And so you should not have holes like this or ones that are similar to this. You need to create your own design. But these are the 6 holes, 1, 2, 3, 4, 5, 6. And then this is the regular polygon for the practice hole. Notice there's angle measures for each of the angles. The lines that are parallel are the same color. So that's the first design. And then in your report, you need to write up how it's composed. So like hole number 1, which is here, it says this can be viewed as 2 rectangles put together. So you could split it here and I have 2 rectangles. So you have to say how each of these holes are created, what different shapes create those holes, whether rectangles or squares, or you can do triangles and other ones, but I would make your holes simple because it makes it easier to do this project. Then you need to say the perimeter of the hole, the area of the hole, and give the ordered pairs of all the corners of the holes as well as where the hole is located. Okay, and I think in this project, they're missing where the hole is located. So make sure that you have a location of where the cup is that the ball would go in when you play the hole for each of these, which is missing from this report. So you can read through kind of their descriptions for each one. Then you need to explain the practice hole and give all the interior angles, the exterior angles, and the central angles. Okay. And then the area of the practice hole you need to give in the perimeter of the practice hole. Okay. Then you need to do walkways. So I would draw the walkways in. I think for them, the walkways is just all of this yellow is considered the walkways. And then they found the area of that walkways by counting how many squares there were. And then describe the obstacles. So describe what obstacles are there, and then you need to find the surface area for the obstacles, and then the volume is how much water is in the obstacle to ground it. And then this is the cost of design. So do not use these costs. This was made a lot of years ago, so I'm pretty sure the costs are very outdated for what the prices are now. So you need to look up your own costs and calculate the total cost. And there's also, I think, a mistake. I believe the concrete for the walkways is not calculated correct. So make sure that you're not just copying exactly, make sure you understand of like how to calculate the concrete, the paint, the carpet, and the lumber, and then calculate it, because again, I believe there is a mistake in this so that it doesn't work. And then the second design is the first design kind of transformed. So these holes are rearranged using reflections, translations, rotations, and so they talked about it. Now, again, this one does all translations. It is required that you do at least 2 different transformations. So you cannot just do all translations, but you'll explain how do you get the new hole 1, how do you get the new hole 2, and all of that. And then you discuss about the technology you used and answer the questions that for the write-up. Okay, so that is the project. Let me know if you have any questions, and I'll do a video with GeoGebra to help with that part.